All right, so we wrote our series in summation notation, but we haven't actually found the sum yet using that. So if I asked you to find the sum of a finite arithmetic sequence, that means a arithmetic sequence that doesn't go on forever, that stops at a particular number. To find the sum, we use this formula. All right, so if we take a look, right, and remember this first part is just the notation. This is just summation notation. It tells you you're finding the sum. The n is our top number here, remember, and if we don't have that, if that's not written there, if instead we have a list, we're going to have to find that. That is the term number of our last term. Remember that this is our first term. And then don't forget that D is our common difference. Now, if we're finding the sum of a finite geometric sequence, we're going to use this formula instead. We still have our first term in there. This time we have a common ratio or common quotient, same thing. And we still have our n in there, which is the last term number that we were on. So let's give it a try. All right, so if we are finding the sum of this arithmetic series, then that means I'm going to have to use our formula, n over 2 times 2 times a sub 1, the first term, plus n minus 1 times the common difference. And I'm going to have to substitute those values in. Well, right now I know a sub 1 is 2. Here's a sub 1. And I can look at it and just figure out quickly what the common difference is. So 2 to 4 to 6 to 8, every time it looks like I'm adding 2. That's everything except n. Remember, n is the term number for our last term. So I need to find n for my last term of 70. Right, in order to do that, I need the equation for this. So I need the equation of this arithmetic sequence. So I know to find it, a sub n equals, it's arithmetic. So I'm going to start with what I am starting the sequence with, my first term 2, and every time we're adding 2 times n minus 1. So I know that my last term was 70, and I'm solving for n. All right, so let's see. 2n minus 2. The 2's cancel. So n equals 35. So now I have everything I need to find the sum of this arithmetic sequence without having to actually put in my calculator 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 all the way to 70. All right, so n is 35 over 2 times 2 times the first term was 2 plus 35 again minus 1 times the common difference was 2. All right, and we find that value, and we find that the sum of this series is 1,260. All right, so now we need to find the sum of this geometric series. So we'll use its formula. So this is for a geometric series. Okay, and again, I don't want to have to 4 minus 4/3 plus 4/9 minus 4 over 27 plus and figure out the next term and the next term and see how many I would get to the end. Okay, so instead I'm going to use the formula. So in my formula, I need a sub 1. That's 4. You can see that here. I can look at it and figure out what r is. So I can either take a past term or take the two successive terms and divide them, or I can just say 4 times what is negative 4/3. Negative 4/3 times what is 4/9. Okay, and every time it looks like I'm multiplying by negative 1/3. All right, and I need to find n. Okay, and in order to find n, this time I can kind of look at the last part here because this is kind of my equation. Normally my first term, or my equation, would be first term times my common ratio or common difference to the n minus 1 power. But I don't have n minus 1, I just have a 10 here. So we can just tell that n had to have been 11 because 11 minus 1 is 10. So I have everything I need now. So my first term times 1 minus my common difference, common quotient, to the n power, which was 11, all over 1 minus negative 1/3 again. Be careful, notice at the top I had that extra set of parentheses because it was negative to the 11th power. And when I find that value, I get that the sum of this geometric series is 3.0000016935. So, yeah, I mean, I guess I could say that it was 3, but it's not exactly 3. So you might say 3.0 approximately. Maybe have all those zeros, 3.00002, just to know that it wasn't exactly 3, but this is acceptable. Don't just put 3, though, so we know it wasn't exactly 3, but it's very close.